Sophie Cath, Senior Business Development Manager at NRM, and I'm delighted to be chairing the session today. Sulphur plays a critical role in crop health, nutrient efficiency, and overall yield, yet its importance is sometimes underestimated in modern farming. Today, we'll explore how sulphur availability has changed, its essential role in plant nutrition, and whether it has become a limiting factor in crop performance. We have a fantastic lineup of expert speakers who will provide both scientific insights and real-world data, helping us understand how to optimise sulphur nutrition for better results in the field. Before we begin, here's a quick look at today's agenda. We'll firstly be hearing from Professor Steve McGrath, who will discuss the essential role of sulphur in crop nutrition. Following that, Dr. Sajjad Awan will present a review of NRM data, examining whether sulphur has become a limiting factor. Finally, we'll have 15 minutes allocated for Q&A, where I'll be fielding your questions to our speakers. The webinar will last no longer than 1 hour. A few notes on housekeeping. Please submit your questions via the Q&A facility at any time during the webinar. I'll collect these and put them to our speakers at the end during the Q&A session. There is one basis point available for attending today. So for those who would like a basis point, please put your name and basis number into the chat function, not the Q&A function, the chat function, at any time during the next 60 minutes. And just so everyone is aware, this webinar is being recorded. Now, I'd like to introduce our first speaker, Professor Steve McGrath, a distinguished soil and plant scientist at Rothamsted Research. Steve is a globally recognised expert in plant nutrition, soil science, and trace elements in agriculture. With extensive research on nutrient cycling and soil-plant interactions, he brings a deep scientific perspective on the role of sulphur in crop health and productivity. Over to you, Steve.
Well, good afternoon, everybody. Okay, I'm going to tell you this afternoon about why sulphur is essential, really, for yield and quality. Over the many years, we've realized that sulphur definitely is an essential element for animals and plants. And now I think the need for sulphur fertilizers for crop yield and also for quality of the crops produced is very widespread in this country. In fact, to my mind, the sulphur is the second major nutrient that you should be considering for crops when you're thinking about fertilizers and crop nutrition. The reason I say that is because nitrogen, of course, is the big one. Everybody knows nitrogen is our first consideration, but sulphur is second, I think, because talking about the major nutrients, so nitrogen, sulphur, phosphorus, and potassium, most of our soils are pretty well supplied with phosphorus and potassium. For example, in this country, we know that phosphorus has been applied for many years to soils. And if you look at, these are some NRM figures for average values of phosphorus coming in from samples they've had over the last, say, 20 years or so. The mean phosphorus is actually in arable and grassland samples higher than the recommended amounts. As you can see, the optimum is seen by the black arrows. And the potassium is around about, let's say, the recommended amounts. And actually, a lot of our soils are well supplied with potassium. Not all of them, but because of clay content and the buffering that provides, there's quite a lot of potassium available in our soils. And so that's why I'm promoting, if you like, sulphur. It used to be talked about as the fourth major nutrient. I'm promoting it to the number 2 position. Now, why is that? Well, sulphur is essential, as I've mentioned already, for making sulphur-containing amino acids and proteins in all crops. And sulphur deficiency, therefore, leads to a decrease in chlorophyll, very important, decrease in protein, and decrease in nitrogen use efficiency. And so, therefore, overall, as you can imagine, poorer plant growth. So in that respect, sulfur deficiency, if it's severe, decreases a lot of physiological activities and metabolism in plants. So first of all, a decrease in protein synthesis, a rapid accumulation of basic amino acids, that's unincorporated amino acids, arginine, glutamine, and asparagine. Asparagine I'll come back to, it's a quality issue. And also as a consequence of the rapid accumulation of nitrate in the plant tissues, a decrease in the nitrate reductase activity, that's incorporating nitrate towards proteins. It actually suppresses nitrate uptake and therefore decreases nitrogen use efficiency by the plants. So you can say, therefore, and you can see this very clearly, what's going to happen is this expensive nitrogen is wasted and lost, and possibly other nutrients because of poor plant growth and root growth. So let's come to look at the overall picture of sulfur dynamics. This quite complex picture really basically determines what's happening above and below ground. With fertilizers now very important in terms of supplying sulfur. We'll come to that in a minute. But what I want to emphasize here really is that sulfate is the central factor in the whole thing, because that's the form the crops take up, and that's the thing that we have to supply at the right time for crop growth and for quality. So how can we diagnose sulfur deficiency? Well, first thing is visual symptoms. Severe symptoms like these in oilseed rape and in wheat, winter wheat here, appear in the young leaves. That's to say the top leaves which are formed on the plant, rather than with nitrogen deficiency, which is also causing a kind of yellowing. That tends to be more prevalent on the older leaves, where the nitrogen is retranslocated from those leaves towards the growing points of the plants. So visual symptoms are sometimes difficult to spot, but you can get your eye in. This is two of our plots on the famous Broadbalk experiment. On the left, received no sulfur since 2000, and on the right, received sulfur and all the other nutrients. And you can see here, I think particularly if you get early morning light or late afternoon light shining sort of at the side of the plants, it kind of lights up and you can see visually the light green top leaves with the sulfur deficiency on the left. So on this experiment, as I said, we've left off sulfur for about 25 years now. You can see very clearly the difference in sulfur. You can actually see it from the air. Plot 14 is, as you can see to the right of the letters Mg, is quite light green. And we have a paired plot, which is plot 9, receives the same nitrogen, phosphorus, potassium, and sulfur and magnesium. And you can see it's actually very, very dark green. So, like I say, visual symptoms can be really quite apparent and therefore lead to, in the end, quite big differences in growth. These are some of the wheat results here. We've got a difference in first wheat of 0.62 tons and in continuous wheat of about 0.12 tons. So coming to diagnosis then, cereals are likely to respond, actually we know from experiments around the country, on lighter and medium textured soils than heavy clay soils. And sulfur deficiency can be diagnosed then by analysis. So sampling whole shoots, stem extension, we've been using a value of less than 0.2% S in dry matter, and for grain, less than 0.12% at the end of the season. However, it's quite interesting. This is 6 randomized controlled experiments with and without sulfur fertilizers around the country. And we began to realize that it's not the responsiveness or not of an experiment is not just down, for example, to soil analysis, but also nowadays it depends on, well, actually climatic factors as well as soil factors. So making sense of these 6 experiments, some of which you can see responded largely, hugely, and some of them didn't. November to February, which is overwinter rainfall, was a very important factor. And so we came up with this likelihood, the risk, in other words, of sulfur deficiency. It depends on texture, so sandy, medium, and heavy soils. And then across the top here, we've got low, medium and high overwinter rainfall. And this just shows that the climate and the soil texture affects how much of the sulphur, which is mineralized over the winter, is actually washed out by the time it comes to the rapid growth period for crops in the field. So that's in spring. Coming to oilseed rape, it's very responsive because it has a high sulphur requirement. Spring rape crops are possibly less susceptible because of the lower yield, lower uptake, and a value of about 0.4% in leaf material analysed indicates likely deficiency. So changing to the second part of our theme, which is crop quality, I've got a couple of examples here. This is the dough extensibility. So this is the sulphur effect on the bread making quality, if you like, which is measured by extensibility. 3 different bread making varieties were grown, and you can see with the sulphur additions, we had different amounts of sulphur in the grain and a very clear relationship with the bread making quality here. Second example is acrylamide, which is actually formed by, I mentioned before, asparagine. We now know that the asparagine is transformed during baking into acrylamide, which is a negative thing. And sulphur application can actually decrease this to a certain extent. So in fact, we are recommending putting on at least 20 kilograms of S per hectare in order to control asparagine and therefore acrylamide. Going to the bigger picture, so what has happened over the years with sulphur emissions and fertilizers. This graph shows quite nicely, as we cleaned up the air, the sulphur emissions and therefore sulphur deposition to our crops has decreased enormously over time. And fertilizers, you can see from the line on the right, have begun to take over. We don't need as much sulphur as we used to get from the air, but the main thing is that we're putting on enough sulphur fertilizer. This is an example of percentage area of some of the crops receiving sulphur from the British Survey of Fertilizer Practice. And you can see because of that decrease in inputs from the air, we've needed more and more sulphur application over the last sort of 25, 30 years. And very clearly you can see for some of the major cereal crops and oilseed rape, this increase in the area which is receiving sulphur fertilizers is very, very clear. On the next slide, I've added grassland there. You can see the 2 graphs at the bottom. All grassland, I'm assuming, includes a lot of extensive grassland, which is not regularly receiving a lot of fertilizer. For the green line, which is less than 5-year grass, I'm assuming that's really high productivity grassland. And I think, as you can see here, the data is a bit discontinuous for the 5-year grassland, but I think there's actually too small an area which is receiving sulphur on grassland, possibly because farmers are thinking that the organic manures may actually supply enough sulphur, but we'll come back to that in just a moment. So here is a sulphur supply from organic manures. This is from some work that was done on different types of manures. As you can see, different organic materials applied in the autumn or in the spring. And the key point here is that whether you're using this on arable crops or on grassland systems, the sulfate content is important. So if you look at the available sulfate, actually as a fertilizer, it's expressed as SO3. But if you look at the available sulphur, it is only a proportion of the total which is applied. So the example in the graph on the bottom, if you think you're applying something like 25 kilograms per hectare of SO3, what is actually available as sulfate is only 11 kilograms per hectare. And for most crops, you're going to need at least 20 to 40 kilograms per hectare of SO3. So it's not enough. It's a bit like nitrogen in that sense. A lot of losses take place, as I mentioned, over the winter, so sulfate and nitrate. losses, particularly over the winter. And you're going to have not enough sulfate available at the time the crop is rapidly growing. So coming to application rates, the SO3 application rates here, you can see are what we are thinking is the right amount for arable crops. So we'll see rape at the top, for cereals in the middle. For grassland, the recommendation is 16 kilograms of sulfur per cut. And as you can see from that black line, it has actually been trending down since about the year 2000. But it is per cut. So if grass is cut, for example, twice, it will be 32 kilograms. If it's 3 times, it'd be 48 kilograms. So we're around here, around about 30 to 40 is being applied. So where it is applied, which, as I said, is probably not in enough cases, the amount seems about right where it is applied, but it's not applied everywhere. Okay, so coming to some conclusions, what I've been saying is now we need routine sulfur fertilization for crop yield and quality in the UK. There's little residue effect because we know from experiments that if you don't put it on the next year, you don't get much of an impact because it washes out basically. Organic manures, as I said, are supplying sulfur, but they probably don't provide enough for grassland or for arable crops compared to the requirements. And the risk relates really to both the soil type, soil supply, or the soil losses, if you like, and overwinter rainfall. And it's quite clear now we've got very big increases in yield, increases in fertilizer use, enhanced bread making quality, and decreased acrylamide in wheat in particular. For oilseed rape, we've also got those big increases in yield and nitrogen use. What I haven't shown is there are decreases also in green seed and glucosinolates, which are also quality parameters. The cereals, the increasing deficiency has led to yield responses probably in the region of detectable, that's 0.3 to about 2.5 tonnes per hectare. And the cost to benefit ratio of applying sulfur fertilizer we've worked out is roughly between about 3 to 30. So there is a good large benefit. We talked about the bread making quality. Of course, if you've got contracts for bread making wheat, that's important. And the optimum rate for winter wheat in particular is between 25 and 50 kilograms of SO3 per hectare. And the optimum timing is early spring up to stem extension, or making sure that whatever fertilizer you use, there's enough sulfur available at that time. For oilseed rape, it's a similar system, but higher requirement and actually a higher benefit. Cost-benefit ratio there of application is between 3 and 70 times the cost. The higher rate of application, that's 50 to 75 kilograms of SO3 because of the high requirement. And again, the requirement is again during the rapid crop growth. For grassland, I haven't said much about grassland, but I know from experience that there are big increases in yield on grassland, but there are very few controlled experiments compared to the other crops. I think the sulfur may be a little bit forgotten in terms of grassland because I think too little of the grassland area receives sulfur fertilizers, and that's in the statistics. And as I mentioned, 16 kilograms per hectare per cut. And it's important not to forget it's per cut. So if you have 2 or 3 cuts, it's important to put more on. And the optimum timing, of course, again, is when early spring growth starts, but then after each cut. So finally, what I'd like to say is to thank particularly AHDB for funding a lot of the work that we've done on arable crops and sulfur. BPSRC here for the facilities that we use, and Chris Dawson, I thank him for making the fertilizer survey slides. Thank you very much for listening. Thank you.
Thank you very much, Steve. That was really insightful. Looking forward to delving into that in more detail in the Q&A. So now, building on from that foundation, we'll take a closer look at whether sulphur has become a limiting factor in UK soils. This will be presented by NRM's soil and crop nutrition agronomist, Dr. Sajjad Awan. Sajjad's had over 15 years of experience in fertilisers, soil nutrition and agronomy, with a PhD in plant physiology and molecular biology. He played a key role in developing AHDB's Nutrient Management Guide, RB209, which underpins fertiliser recommendations across the UK. His expertise spans soil health, regenerative agriculture, and data-driven nutrient management. Over to you, Sajjad.
Hello, thank you, Sophie. Thanks for a nice introduction. So I'm Sajjad Awan. And today I'm going to present some of our data that we have gathered over the past few years, specifically looking into sulphur. For those of you who don't know who we are, NRM is actually UK's largest independent agricultural lab. So on average, we analyze around 500,000 soil samples annually. And there are certain days in a year that we receive 3,000, even 5,000 samples a day. So you can imagine that we have built up a very large data set. So making use of that data, today I'm going to share with you what we have found in terms of soil sulphur, plant tissue sulphur, and grain. And yeah, so when I was looking at this data, actually, I was really surprised how critical situation has become regarding sulphur in the UK. So this data, with soils, what I'm gonna share with you here is the data ranges between 21 and 23, so 3 years worth of data, and this data comes from just over 7,000 field samples across the UK. Right, okay, before we delve into the results, I will be talking about this normal distribution, because when we look at large population, large data sets, there is a certain way of looking at this data, and drawing a normal distribution really helps to see what's going on. So here, this is an example for winter wheat. So on average here on this graph, you can see that the mean is 8 tonnes per hectare. 50% samples below 8 tonnes per hectare, and 50% samples above 8 tonnes per hectare. So it makes a really nice bell shape. And this shows that this data is actually normally distributed, and this data is good enough. So it's normal, there's nothing wrong with it. And that's how we expect in statistical terms. The reason I'm showing you this is that I will be using a lot of these when I get into the data. Right, okay, so let's look at the results. Now, this is from, as you can see, this data is from 2021. And it shows, you can see that the graphs actually, or the distribution is mostly towards the lower end of the spectrum. So most of the samples that you're looking at during 2021, they range between 15 to 25. Ideally, they should be somewhere around 40 to 45 or even above. So this is 21. If we look at 22, you can see despite different weather conditions, climatic conditions, not massive difference. So both distribution curves, they're overlapping quite nicely. And 23, there is a big increase in towards the lower side. And that could be attributed towards, it could be the weather conditions again. But if you look at the bigger picture, all these three distribution curves, they are overlapping. So essentially, there is not much difference. So most samples that we're looking at here, they're deficient in sulphur. This is soils. Now, what are the implications of this? So we know that if the sulfur deficiency is, if the soil sulfur content is less than 20 parts per million, or here we've shown milligram per kilogram, then you can see that the crop will definitely respond. Most likely the crops will respond. But if it is between 20 to 40, then moderate likelihood that they will respond. And above 40 milligram per kilogram, they will unlikely respond. But if we look at this data, now let's look at this. So majority of what we're looking at here, around 85% of these 7,000 field samples, they are well below where they should be. So it's about 15%, less than even 15% of the samples which have got sufficient sulfur in them. So this indicates really bad situation in terms of sulfur. Now, then what we did, this prompted me to look into other tests, and another one that we do is actually, we call it crop check, but this is tissue analysis. Essentially, Steve mentioned earlier about the dry weight tissue analysis. The data that I'm going to share here is winter wheat data, specific growth stage 32 to 37, and they nearly 2,000 samples from winter wheat. So again, these samples, they come from the same 3 years, 21 to 23. Right, okay, so the first thing first, the curve looks really nice, normally distributed, but the issue is that the samples are way too low in terms of nitrogen. So I should mention that we're not looking at sulfur here, we're looking at nitrogen concentration. So this is just, I just wanted to see which of these nutrients they contribute towards the yield. I'll come to that in a minute. So looking at nitrogen levels, 2021 quite normally distributed, but the sample concentration quite low. 22, a lot of samples, you can see that spike towards the higher end. But essentially, if you look at the curves, they're not much different. However, 2023 was quite significantly different. What does that mean? It means if you look at the curves, again, 21 and 22, they quite closely, they're overlapping quite nicely. That means not much difference, but 23 shifted towards right with high concentrations. You think that the yield may be explained nicely with high concentration of nitrogen. But actually, if you look at the graph on the right-hand side, so this data we got from DEFRA statistics, and that shows that the highest yield was actually during 22, not 23. So then we looked into phosphorus and we looked into potassium, but we could not find much of the difference. But when we looked at sulfur, that was quite interesting. Again, you can see that, as Steve mentioned earlier, that this is where the samples should have been, around 0.2. But a lot of samples during 21 was shifted towards the left, means much lower concentrations during year 2021. When you look at 2022, you can see that there is a big shift towards the right. And the curves actually not overlapping with 21. And if we look at 23, you can see that the curves actually 21 and 23, both of them, they're quite similar. So that means that 21 and 23 are not contributing much, but 22, you can clearly see there that the highest yield coming during that year. So this gives us, it's not conclusive, it's not a done deal that actually this sulfur is contributing towards the yield, but actually there is something happening. So this prompted me to look further into the data, and what I did, actually we put all the nutrients together. Before I go and show you that part, I would quickly remind people that, you know, these correlation graphs. So if you increase X, Y will also increase, and the R squared value in statistics, we say it's 100% or 1. So this is 1, shown as 1. Whereas on the other hand, if you increase X, Y decreases. So the R squared value in that case would be -1. And that's what I'm going to share with you next. So this is called pairwise correlation matrix. So what we've done, we've got the same nutrients plotted on the top row and the first column. So, and the corresponding values to those are actually R squared values. They are, I think they're 54 altogether. Rather than showing you all those 54, we thought it's a good idea to use this correlation matrix. So for instance, if you compare nitrogen with nitrogen, you get a correlation of 1. But if you compared nitrogen with phosphorus, a very strong correlation. Just to remind the audience here, we have got 3 years worth of data, more than 2,000 winter wheat samples. And this is growth stage 32 to 37 data. Well, this is quite a strong correlation with nitrogen and phosphorus. That means both of them, they're playing a positive role to improve the uptake and utilization. Similarly, nitrogen got a strong correlation with potassium. Look at the correlation between nitrogen and sulfur, really strong, so nearly 80%. So this explains that both of them, as Steve mentioned earlier, that utilization of nitrogen won't be possible if sulfur is deficient and vice versa. So a strong correlation between phosphorus and potassium, but I would like to draw your attention to sulfur row right at the bottom and see how many different nutrient elements are strongly correlated with sulfur only. So most likely here, so this data suggests that actually sulfur is playing a vital role in uptake and use of those nutrients in the plant tissues. Right, okay, so this data is, again, crop tissue data. Let's move on to the grain data. So we call it grain check, grain analysis. Again, we've got slightly more than 6,000 samples, same years, 21 to 23, winter wheat. Now, this data means it shows a lot of other things, but if we just focused on sulfur here, just to get your attention to a sulfur, the range that we used here, we've been quite liberal actually. We used a range between 0.1 to 0.12, rather than just sticking to 0.12. So look at the number of samples which are deficient in sulfur, nearly 41%. And if we only use 0.12 as a benchmark, then I would say way more samples would be deficient in that case. Similar would be the case with nitrogen and obviously with phosphorus. Phosphorus is probably, we are reviewing that information. Right, so here, as I say earlier, that we have got these samples, that we have all those samples showing that sulfur is deficient. Soil has shown it. Tissue and grain, they're all showing the same thing. Sulfur has seriously become deficient across the board. We need to review what we're doing. Crop tissue analysis is a very good way if you want to identify, but the timing must be quite right. If the timing is wrong, it might not be useful. One important point here is about the grain analysis. I always call grain analysis is the post-mortem of your nutrient management plan. So how well your nutrients that you applied, they were taken up and utilized by the crop in terms of yield. So grain analysis is a must, I would say. for all of your nutrient management plans. And the last thing is about the climate change. So remember that we used to have 5 years in a row, we had very dry run of springs where the applied fertilizer wouldn't be washed into the ground. And then we, after that, I think starting 22 onwards, it's been quite wet. And springs are very cold as well. They're not spring-like. So nutrient availability can be compromised under very wet, very dry, very cold conditions. And with that, I will hand it over back to Sophie. Thank you.
Thank you, Sajjad, for that really great presentation. Now, I'm sure both talks have given everyone plenty to think about. I can already see some questions coming in, so let's dive straight into the Q&A. Just a reminder, I have noticed that some questions have been popped into the chat function. Please do put them into the Q&A. It'll be easier for me to manage. So if you hadn't had a chance to ask yet, now is the perfect time to send in your questions about sulphur and its role in crop nutrition. But before I bring back our speakers, I'd just like to introduce Ali Arden, Agronomy Manager at NRM, to the Q&A panel today. With over 20 years in agronomy, including 2 decades as company agronomist at CF Fertilizers, Ali has led major R&D programs and developed technical services for fertilizer and organic input management. As an independent agronomist, she continues to advise on manure management, soil health planning, and sustainable land management, helping turn agronomic science into real-world farm solutions. So thank you, Ali, for joining us today. So let's get started with our first question. This probably is relevant for Ali, actually, considering her background in organic manures. So what is the S content roughly in plant digestate? Do you have an idea on that side of things, Ali?
Well, off the top of my head, hello everyone, by the way. If you look in RB 209 section 2, there is some guidance for digestate materials. So there are some values in there for food-based and for farm source. So that would be your first port of call. And I think in there it separates them out. So you've got the whole material, and then if it's separated, the fibre and the liquid portion. So you can look at those and get values from there, or of course you can analyse it. So that's part of the story. The second part of it is sort of estimating how much will become available, and that's a real difficulty, because the great work that Steve summarised from RB 209, where they're looking at availability proportions from different types of manures, didn't include digestate. So there's some gaps in knowledge. So what would you do in that case? I suppose if it was me, I would definitely get the material measured, and then I would have a go at estimating what I felt the release of sulphur might be. And the release of nutrients, nitrogen and sulphur, it all is dependent upon when you're applying the material and it complexing with the soil. So there's quite a few parameters, but it is about trying to estimate how much you feel should be there. And it's probably erring on the side of caution and underestimating perhaps what's going to be available from manures, and making sure you supplement enough from applied fertilizers. A bit of a cop out, but RB 209 does start to give you some guidance.
Great. I was about to ask that. So RB 209 is a good place to start in terms of how to estimate those figures.
Yes, I would go there. And yeah, make that your first port of call. But measuring all organic materials, in my view, is the best way to start. And the more farmers that can analyse, I think the better we can be in terms of trying to target inputs a lot better, not just for sulphur, but for all nutrients. So that would be my first protocol, and that is what I try to persuade as many of my farmer customers as I can.
Absolutely. And I think we've got another question that probably leads on quite nicely to what you've just said there, Ali, around plants that can fix sulphur or that can bioaccumulate it, which can then be cut and dropped. Have you got any steer on particular plants that might be able to do that?
Steve might be able to explain if he
Yeah.
knows of any that fix. So I'll let Steve answer
Yeah.
that part.
It's not particularly fixed, because fix sounds like, you know, nitrogen fixation from the air. It's there are plants which are very rich in sulfur, put it that way. And I mentioned, you know, brassicas. So any brassica sort of break crop might be very rich in sulfur because they accumulate a lot of sulfur. And then, of course, if you make sure that's incorporated, that sulfur may be more available for the next crop. We haven't done specific experiments on that, though, I should say. But potentially any brassica break crop or in between, you know, sort of overwinter crop would have a residue that was sulfur rich. And the key thing, again, like everybody's been saying, is that then available to the next crop in the spring?
And is that something, Steve, out of interest that you are looking to explore more at Rothamsted in terms of further trials in this area?
No, we did some work obviously on the nitrogen carryover from break crops, which showed small effects actually. But no, nobody's ever looked at sulfur.
Perhaps a real gap there, maybe we can look at for the future. Great. So we've got another question around methodology. So I think that's best for Sajjad. What are the sulfur measurement methods, Sajjad?
Right. Okay. Just to first of all, I would say that I'm not a chemist by any means, and I don't work in the lab, but I know that there are quite a few methods available for sulfur if you want to identify. So we use ICP, Aqua Regia reverse solution, and then we use ICP OES. So these are the instruments that we use to measure sulfur in the tissues. But there is a very good test which we don't provide at NRM. It's called malate sulfate test, which is actually mentioned quite a lot, and it's found to be quite useful. Mentioned quite a lot in RB29, and there is scientific evidence that it is quite useful. For soils, we measure sulfate again, and yeah, so means that is my knowledge. And if Steve wants to add anything, that would be very
very I can just underline that. So basically with plant material, you digest the plants, whether it's grain or leaf or what have you, and then do ICP sulfur. For soils, it's usually a very weak phosphate solution that we extract with, and then you measure the sulfate in ICP. And for manures and things, it's a bit like treated like plants, so that would be digested in the same way as plant material, and measure either the total sulfur, or as it's been emphasizing, the sulfate in the material. So you'll find if you have a different types of manures, there'll be different sulfate contents in those. The immediately available sulfur can be measured.
Brilliant. Thank you, Steve. I've just noticed someone has raised their hand, one of the attendees. Perhaps easier if you've got a question to pop it in the chat, if you don't mind. And so move on to another question around relationships between soil organic matter and available SO3. Do we have any data that has looked at that? Perhaps one for you, Sajjad?
Well, I mean, this prompts me to do my further data analysis, because the reason for looking into the soil, tissue and grain sulfur was that there was very high demand. A lot of people were asking me this, that have you looked into this? But to get this right, I mean, so far I haven't done it, but that is my first next project, I would say. Right. Steve wants to say something.
Yeah, I'd add to that. Yeah, we had a student, and we made some publications probably about 20 years ago now, Basically, we have long-term experiments where we've got a long-term, grassland, woodland, and farmyard manure treatments, as well as inorganic fertilizer treatments. So the student looked at those, and yes, you do get more mineralizable sulfate from our, let's say, organic treatment, so organic manure, or if you've got long-term grassland and very high organic matter. The question, though, is whether that's enough again at the time of spring growth, if there's enough sulfate being mineralized at that time, rather than being washed out. So again, it's the same story really as with nitrogen. Quite a lot of manures are applied in the autumn, and there's a lot of mineralization while there's almost no plant growth. And during that winter period, because we've got excess rainfall, a lot of the sulfate and nitrate washes out. So how much is left at the time that plant really needs it and needs to take up a lot very rapidly is always the key factor. And I think that we concluded that even with farmyard manure, it's not going to supply all your sulfur in spring, and that you need to make some more available. So that's the story from long-term experiments. And there may be some sort of relationships, as you've just said, in the national data if you look in detail, Sajad.
Definitely.
Thanks, Steve. That's really interesting, and partly connects with something you said in your presentation, Steve, just around grass and the fact that there is a real lack of sulphur being applied there. Perhaps there's too much reliance on organic manure, which may not be measured. I mean, Ali, from your perspective, in terms of the more practical on-farm experience, you deal a lot with livestock farmers. Do you have a kind of an opinion on why perhaps not enough sulphur is being applied on grassland, and how we might be able to change that?
I think there's a couple of things. I think one is the manure argument that Steve presented, that farmers are thinking that manure applications are delivering enough for the whole season maybe, and because let's face it, if you're in a livestock dominated area like I am up in the northwest, there's much more organic manure really than our land bank can take. So you'd think with the sort of with the volumes that a lot of land receives in the west, that there would be, but it's a case of the availability and when the sulphur is it available at the right time. And I suspect that that's where quite a few farmers are going wrong, assuming that there's enough throughout the whole season. The other aspect is, which I think is that in the livestock sector, we tend not to technically sell, I would argue. So farmers don't always get offered fertilizer analyses which might even contain sulphur, or they might not even be requesting it of wherever they buy their fertilizer products from. They might not even be requesting that they are supplied a fertilizer that contains sulphur. So I think there's perhaps that's playing a role, and I guess that us advisors have got to be really pushing this message that if you want good quality grass that's palatable, that's got high water soluble carbohydrates, and the quality is there for the stock, that we really want to be suggesting that farmers buy, more balanced products that can deliver the right amount of sulphur. So, yeah, I think it's a bit complex.
No, I think you covered that nicely, Ali. Yeah, that's something we definitely need to address. Thank you. So another question here. NRM have been great sponsors of Yen. Thank you very much. And the question is around, do you think sulphur recommendations are high enough for high yielding crops? Perhaps one for you, Sajad?
Yeah, I was thinking, while doing the analysis, I've realized there are recommendations in place, but if you read RB29, it suggests that not all crop requires sulphur. Means I think we need to make some changes, basic changes in RB29, and one of those seems like it that most crops now they require sulphur. Now, coming back to the rates, it seems it could be the case. One argument that we're discussing here is the application timing, that, you know, we think that the manures and slurries and digestate, all those, they are making those nutrients available when the crop is rapidly growing. That's one piece of argument. The second one is whether we think that what we are applying is enough. I think there is a requirement we need, because obviously Arbiter 9 is an empirical evidence-based document, so we need to do some trials, and on the basis of those trials, hopefully we can make those adjustments. But most likely, it seems, as Steve mentioned earlier, sulfur is not coming from atmosphere anymore. We've got much cleaner air, so there is no source available now. That means that we may have to rethink our strategy. And sulfur, last update, we did not do much. We didn't have enough data in the previous version when we published in 2017. So yeah, we do need trials so we could update those recommendations.
Thanks, Sajjad. Yeah, interesting point there. And actually one of the questions in the chat links quite nicely in terms of how can we get more sulphur into the crop. This person said interest is growing in the use of foliar application of nutrients. Can sulphur be applied via this method? Perhaps one for Steve, maybe?
Yeah, it can be. I don't think it's very common actually, but any sulfate containing fertilizer could be sprayed on the leaves about the same rate, because yeah, okay, you think that the leaves are receiving all the sulfur. They don't. It drips off onto the soil anyway. So yeah, it goes in through the root system. But I would suggest the same rate with foliar fertilizers, but you could perhaps split it during the rapid growth phase of the crop rather than hitting it all at once. You could split it like nitrogen fertilizer. It's split when it's broadcast. So yeah, sulfate should be just as available and just the same amount, I think.
Brilliant, thank you. And whilst we're on you, Steve, just a brief question was, someone's asked, was there a reason why the GRASP recommendation for sulphur per cut was given as kilograms of sulphur per hectare instead of kilograms of SO3 per hectare?
That might have been a typo. It should be 16 kilograms of SO3 per hectare.
No worries, perfect.
Yeah,
thank you.
It's a strange thing, but SO3 doesn't actually exist, but the fertilizer regulation said it has to be labeled as SO3.
That's right.
I think we've got one for Ali here. Is there likely to be a sulphur response on potatoes, often grown on light soils with no winter cover?
Possibly. I mean, potatoes aren't known as a proteinous crop, and I think that there are recommendations to apply potatoes, but it was typically for control of sort of skin diseases like scab, principally, because it affected the acidity. I mean, I don't know whether Cambridge University Farms have done experiments on response experiments on potatoes. I don't think there's a recommendation in Arbiter 9, but it seems there is going to be some response on very light soils, I would imagine, but I don't know what that response rate might be. I don't know whether Steve's seen any data on related to potatoes. Excuse me.
No, no, I haven't seen any. I mean, it depends really on the productivity, as I've shown. You know, nitrogen, the sulfur, and all the other nutrients are making a plant, and you need a certain amount of sulfur for any crop, really. And potatoes make a very big biomass above ground, you know, to fix the carbon. So I would imagine that the requirement is equally high to build a good plant. So, you know, I'm surprised nobody's done the work on potatoes, but there doesn't seem to be any, not that I know of. Also in the chat, there's the mention about sugar beet. Again, very little work on sugar beet, but I think there is some data on sugar content of beet being increased by sulfur. So, there is a sulphur requirement for all crops. It's just working out what it is and then supplying the right amount.
Just to add, Sophie, into the question, means the matrix that I shared earlier, all the nutrients aligned together, and sulfur playing a key role in uptake of those nutrients like phosphorus, potassium, magnesium, zinc, boron. So that means that sulfur is absolutely necessary, or as just Steve mentioned, it's vital component into, the certain amino acids. So if they're deficient with a large foliage of crops like potato, they won't grow well. So I'm really surprised that, there are no recommendations, but yeah, so there's a lot of gap to fill in terms of sulfur.
Absolutely. I think I've got another question for Steve here. So do you have a view for other European countries on sulfur crop deficiencies?
Yes, they've been observed across large parts, I'd say, of Northern Europe particularly, so not the sort of dry lands of the Mediterranean. So yeah, whenever you have excess winter rainfall, you now have a sulfur problem, basically. Wherever you're growing high requiring crops, so all of the brassica crops seem to be responding, and indeed the cereals in the same way as they are here. So across, sort of Denmark, Germany, even Scandinavia, which used to suffer from, the so-called acid rain sulfur, too much sulfur, crop responses are shown in all the crops that we've been talking about across quite large areas of Northern Europe.
Fascinating. It feels like, everyone's having a similar issue then, really, in terms of sulfur. So
yeah.
Perhaps a question for Ali here from more of a practical application side of things. Do you have any experience with industrial gypsum as supply material, specifically citrogypsum? Hopefully I've pronounced that right, which is a byproduct of citric acid production. Is that something that you've heard of within your practical side of things on the ground?
Well, definitely gypsum. Calcium sulfate. Yeah, loads of farmers put that on. I have no clue on the type of gypsum that the questioner has. I've got no experience of that, but certainly, calcium sulfate is one source that is regularly applied in the UK. But sorry, I can't answer the other. I don't even know what it is.
Maybe we're missing a trick. So yeah,
maybe we'll
I think we've
research
got
it.
Yeah, absolutely. We've got one final question before we need to wrap up, so we'll have to make this prompt. So the question is, can you give an optimum nitrogen content of leaves? If so, can we work out the sulfur requirements of potatoes, beet, and other crops with little empirical data? Perhaps one for Steve, I think, as a start point.
Well, as somebody that doesn't work on nitrogen, I couldn't give you figures for nitrogen in all the crops, but yeah, there are published data for just about every crop you can mention for nitrogen. Not so much data for sulfur, but there are data around for just about every crop. And in fact, we've done this before for, for things like horticultural crops, which have not been studied. It's just to look at what's their total requirement. So if you've got, say, oilseed rape is at one extreme where you've got a huge uptake, you can calculate that. Yeah. And then at the other extreme, there'll be some, non-brassica crops, and particularly cereals or grasses tend to be at the low end of things. And you can see where your crop of interest is on that scale and say, well, okay, you want to go between sort of 20 kilograms of SO3 and 75 of SO3 as the top recommendation for input. And where does my crop fit along that line? And we did that back in the early days for all sorts of crops and horticultural plants, which we didn't know much about. I think we published it in one of the International Fertilizer Society publications quite a while ago. And that's an approach. If you don't have any empirical experiments in the field, then you can do it by crop analysis and crop biomass.
That's really useful. Thank you, Steve. Apologies we couldn't get to all questions as that has brought us to the end of our 60-minute session. So a big thank you to our speakers, Steve, Sajad and Ali, for sharing their expertise, and to all of you for joining and engaging with such great questions. We hope you found this discussion valuable and that it's given you some useful insights into sulphur management and crop nutrition. If you have any further questions or would like to follow up, please don't hesitate to reach out. Thank you again for your time, and we look forward to seeing you at future sessions. Have a great rest of the day.
Thanks, Sophie.
Bye.
Thanks very much.
Bye.